So in this last word problem that we have for section 4.1, what's challenging for us when you look ahead is we don't only have one linear function, we actually have two. All right, and so I'll try my best to be an economist right now. Classic, what we call linear system that we'll revisit towards the end of our semester. But right now we're going to apply this linear system to what we know in 4.1 and what we know about functions, linear functions that is. So let's read the problem and then we'll try doing some of these things and we'll learn a little bit. So Algebra Gaming tries to sell the hottest math games on the market. Their team of market researchers finds that their best game, Algebra Blasters, which I know you guys all have a copy, has the following supply and demand function. So S of P equals 40P minus 300. And D of P equals negative 10P plus 900. And P in this case represents the price of the game. So how much are we selling the game for, right? So if we're giving it away for free, right, if P is equal to 0, right, then the supply is going to be negative 300. I'm not going to give this away for nothing, right? So negative 300 just ain't happening. However, right, if it was for free, there'd be 900 people who demand it. That's what that's basically saying. And on and on and on. So if I let P, if we priced it at $10, right, 400 minus 300, right, the supply would be 100. So I'd be supplying the market with 100 games. And then, of course, here, this would be negative 100 plus 900. The demand would be 800. So the demand would be 800. So sorry about that. So S of 10 would be 100, and P of 10 would be 800. All right, and so the demand is over the supply. All right, and so maybe we give a little bit more because it's being demanded. So maybe I can raise the price a little bit. Okay, and again, getting into a little bit of economist speak, but hopefully that makes sense about what we're doing here. So supply, how many games I'm willing to put in the market. Demand, how many games the market wants. Okay, and that's about as economist as you're going to get to me right now. So the first thing they want us to find is an equilibrium price. Okay, this is just a fancy name of saying that my two functions, my supply and my demand, are actually equal to each other. All right, so what price does my supply and my demand actually come together? The market's happy and I'm happy, right? Because I'm willing to give this much out to the market and the market's demanding this much. So equilibrium price. So we basically, right, take our S of P. So to do A here, since we're looking at S of P equal D of P, I just basically set one function equal to the other function. And that's how we're going to basically find that algebraically. So solving this, I'd add 10P to both sides and add 300 to both sides. Right? And that's going to give us 50P, and I think that's 1200. Divide both sides by 50, and I know a 0 goes away, 5 goes into 20 twice, 24. So it looks like our equilibrium price will be $24. My supply and my demand numbers will all work out. Okay, so that's how we'd answer the equilibrium price. When are two functions equal to each other? For what price values? I should say is the demand greater than the supply? Okay, so this is one thing we really haven't talked about so far, but I found that it's in the homework, so we better address it. So for letter B, this is what I'm basically saying. When does my demand function, when is it greater than my supply function? Okay, and so to solve this algebraically, again, we're just going to substitute what we know. D of P is negative 10P plus 900, and when is it greater than 40P, right, minus 300? So this is one thing we haven't discussed yet, so let me address it. Solving an inequality is very much like solving an equality. So let's go ahead and do that, and hopefully you'll have some memory jogs and you'll be able to do some of the homework problems. So again, I'll subtract 40P from both sides, and I'll subtract 900 from both sides. So we get negative 50P greater than, right, that's gone, negative 1200. Now, when we're solving an inequality, and I decide to divide by a negative like I'm doing here, what also occurs right? Hopefully your memory banks can remember that, is the inequality changes direction. So P is less than, and we've already done 1200 divided by 50 is 24. So if my price is below $24, my demand is going to be higher than my supply. All right, so there's more people wanting it than I actually have in the supply. Okay, so P is less than 24. While we're on this subject, all right, what we also have to consider is that at the same time, my P has to be greater than or equal, 0 has to be less than or equal to 0. So, so we're kind of getting into that implied domain stuff. So at a very minimum, the price is 0. It makes no sense to have a negative price on something. And then to reach our break-even point, right, is 24. And then anywhere between 0 and 24, my DP graph is larger than my SP graph. Without even graphing anything, you can almost get that sense, because the y-intercept's 900, which is way up here, and it's negative, so it's decreasing. And then this guy is down at negative 300, and it's increasing. So here's the DP graph, and here's the SP graph. We already know that that intersection point's 24, so anywhere between 0 and 24, the demand is higher than the supply. So there's just kind of piecing that together without a graphing utility. All right. Here's where a little bit of economy comes in. What do you think will happen to the price if the demand of the game is higher than the supply? Well, that means the price is going to go up, right? Because, again, if we're sitting here at this value, the demand is higher than what the supply is. So that means that I can actually raise the price, right, and try to reach that equilibrium. As a matter of fact, I want to try to be at that equilibrium because my supply equals the demand. I'm not dealing with a shortage or a surplus, but the price will go up, all right, to try to match the demand, all right? So there you have it. A little bit of economics, a little bit of linear systems, right, and putting it together. Of course, we can show this all in the graphing utility, right? So if I go to, I'm going to have to graph two lines. So we got our supply is 40x minus 300, and our demand is negative 10x plus 900. And again, what we probably want to do is mess around with the window because the numbers are so large. So how about I let my x-min be negative 10 and my x-max, let's let it go out to 50, and we'll go in steps of 5. We already know the equilibrium price is 24, so I'll kind of double that. My y-min, well, we're already at negative 300, so how about I just go down to negative 500 so we can see that supply. And then my y-max, you know, the demand's already at 900, so how about we just make that an even 1,000? And we'll go in steps of 100. So when I go graph that, there's the supply function, and there's the demand function. Again, the supply has an intercept at 0, negative 300. The demand has 0, 900. We do, in fact, see that they're intersecting. So where are they intersecting? We already know the value, but I think it's been a while. If you watch the calculator videos, to find that intersection, we'll go to second calc. We want to find that intersection. I'll trace the first curve till I'm close to it. Trace that second curve close to it. Take a guess and press enter, and lo and behold, it's 24. What's nice about the calculator, though, is not only do I know that the price is 24, but I also know the y value. I know that S of 24 is 660, and I know that the demand, right, of 24 is 660. So what's nice about seeing this on the graph is not only do I know what price makes things equal, but I also know how much I'm going to have to put in the market. We're going to have to produce 660 games, right, in order to hit that price of 24 to reach our equilibrium. Not a shortage, not a surplus. You could also see that the graph of the demand, right, the outputs for the demand are higher than the outputs for the supply from 0 up to 24. So we can basically see everything on our graphing calculator. So that's what's going to be expected out of you guys in your 4.1 homework. A lot of it review of lines in their y equals mx plus b form, right? Fitting this average rate of change idea, that it's basically slope, finding equations of lines, and then doing some word problems where the line's given to you and you just answer questions, right? That was kind of that first word problem, right? So the line was given and we just answered questions. other word problems where they make us find the line and then answer questions based off of that model, and then a third one where they actually give you 2 lines and you basically have to find where they intersect or whatever the case might be, right? And again, we call that a linear system. So that wraps up 4.1. Again, if you have questions, you better ask. Come see me during an office hour. Ask it on Canvas, show some work, share some ideas, and keep on learning. I'll talk to you guys later.